Hi everyone. This is a presentation for the Infinite Melody Maker, which is a project that my team and I have created during this Durhack 24-hour hackathon 2023. This is by me, Jack, Alex, Andy, and Benjamin. So I'll just give you a brief introduction. We are a newly formed hackathon group who just met in Durham in the Durhack less than 24 hours ago. And we all came from different backgrounds. So for me, I studied data science at the University of Manchester, and the others, there's group members from Durham, there's also group members from Newcastle, and we decided to come out with the Infinite Melody Maker because we all found a common interest and passion for music. So previously, when we were brainstorming ideas, we were thinking about doing something finance related actually and targeting the Marshall Waste Challenge. But then we thought about it, and we thought that actually there's going to be a lot of people doing finance related things, and we wanted to be a bit unique and different. So and also because it's such a saturated topic and market. So we decided to create the Infinite Melody Maker. Furthermore, we believe that music is infinite, so it sticks to the current theme of this challenge. In terms of project objectives, the first thing we want is to create melody, so something music related, where users can feel like where musicians can feel like they will get something useful out of this website and this framework that I've created. The second thing is we wanted to utilize recent technologies in machine learning. So I'll bring you through that later. And then the third theme is infinite. So we believe that music is infinite and the notes produced can also be infinite. So this is what our website does. I'll bring you through it later, but the first thing we do is users can input their melodies in the form of notes into the website's GUI, and then afterwards they can also select the scales, which are the constraints they want to use for their song. Afterwards, the back end is our LSTM model will recommend the next few notes, will predict, and it'll also recommend the next few notes that can be used. And then the scale constraints will limit the notes produced to the notes within the scale. And then number four is an output of the recommended notes within the scales chosen are produced inside the website. So this is what happens. This is the website, and you can put in inputs, and then you can use the scales, search a scale, whatever scale you want. Let's say Hira Joshi, and you can enter, and then an output will produce. So how did we use machine learning? As mentioned before, we used an LSTM model. So LSTM stands for long short-term memory, and I'm going to cut this part out. Now, after mentioning the LSTMs, the thing with LSTMs is that it doesn't have the knowledge of.
So this is the implementation of Python. We use pandas, matplotlib, sklearn mainly for developing the artificial neural network. So a lot is done for data preparation as it is a text file and from online resource which is very noisy and dirty. We also use LSTM for building this. So um, so we started with a little bit extra um, job job an A, so to make the data more readable. Then because of the pitch and the search is from A to A B C D E F G with sharps and flat, meaning the musical elements. So therefore we have to transfer it to numeric first, and we have sorted into a list, a numpy list, and then set the equivalent value to the equivalent indices to the value, and then put it into the training of the model. And our model consists of two hidden layers of artificial neural network, and then a final node here. We use the Adam optimizer and the mean square error to fit the loss. we just use the five approach because it is very time expensive to train and test the data and the model. And this we achieve a very good, very nice image of training and validation loss, and a lot of others as well, so we can verify the um, correctness. Later, we also introduced another data set. So we use a different data set to predict what might be the next possible search that might fit into the music, and the prediction shows like this. So 9.020776 is a numeric representation of a search, um, and 9 is probably like the closest search. So it is so 9 the search in position 9 is picked out of 72 or something. And the data set is something like this. So there's a lot of the features, but we're not using all of them because of the input and the time freeze. So we just need a search to predict the next search. And further, if we want to develop this app, we will maybe consider other features as well, maybe even more features than this, such as beats and drums and instruments and many other things. In addition, in addition to what we have, we also implemented a k-fold, so a cross validation for LSTM. Hence, it is the result might be more accurate in terms of predictions and loss functions, so we can see where we need to improve for future for hypo parameters.
Now, after mentioning the LSTMs, the thing with LSTMs is that it doesn't have the knowledge of music theory, right? So it just predicts based on random events and the number of layers inside the long short-term memory. So what we decided to do is we also decided to add a sense of creativity in the form of scales as constraints. So this logic is that we wanted to give the user some choice and context behind where their music direction is flowing. So imagine if you just put imagine if you just put user inputs such as the notes into the melody maker and didn't have scales. It would just come out without any form of direction, like whether the music will be happy or sad. It will just go through the ML model. But having these skills as constraints, the user can you input major if it's happy, or minor if it's sad, or some Japanese scale if they want to sound more Japanese or something. So this sticks to the infinity theme as well, because we're giving the user infinite possibilities, infinite context, and it'll enhance their creativity even more as they can play around the scales and figure what's best for them. In terms of results and achievements, we have created the machine learning model that gives us suggestions of the next node, and we have also created a user-friendly website for users to input their melody. So we are pretty proud of that within this 24 hours. What we wish to achieve in the future is that we plan to integrate these two together so that when the user can enter something, because initially we were just planning to do the machine learning model, and we decided that that was really good already. So then we also decided to flex um, some of our website making knowledge using Flask, and we decided to create a user-friendly website. We have some problems with integrating them together, so that is something we're looking forward to do in the future. Furthermore, we also plan to use audio files, and we basically found this API on the internet where we can convert audio files into MIDI, and in the future, we're gonna give users the option of inputting audio files, converting it to MIDI, and then afterwards using those MIDI inputs, feed it into the LSTM machine learning model, and it'll output the notes required. And lastly, another thing we're excited to do in the future is we're excited to allow the users to play their music straight from the website. So there's going to be a button. I think there's going to be a button right here that says play the music, and it'll play the music and save the music as well. So yeah, thank you. That's the end of the presentation.